The four-stroke petrol engine, also known as gasoline engine, is the most common type of engine used in automobiles today. These are widely used in bikes, cars as the power unit. In this video, working principle of four-strokes petrol engine will be explained. For our daily activities, we require energy to be transferred from one object to another, sometimes as a heat and sometimes as a work. Energy transfer as a heat is quite simple. For example, burning fuel discharges its chemical energy directly into surrounding as a heat. But it's not that easy to discharge chemical energy of fuel as a work. To do that, we require a heat engine. Heat engine is a device which transforms chemical energy of fuel into thermal energy and then utilizes this thermal energy for mechanical work. Now we shall see that how thermal energy of fuel is converted to mechanical work in four-stroke petrol engines. A petrol engine is an internal combustion engine with a spark ignition, designed to run on petrol and similar volatile fuels. In a spark ignition engine, air-fuel mixture is ignited by an electric spark generated by a spark plug. A four-stroke petrol engine is made up of following parts. Cylinder. It is a cylindrical vessel in which piston reciprocates. Piston. Connecting rod interconnects the piston and crankshaft and transmits the forces from the piston to crankshaft. Crankshaft converts the reciprocating motion of piston into useful rotary motion of the output shaft. The big end of the connecting rod connects to the crank and can freely rotate on the crank. The smaller end of connecting rod is connected to piston using gudgeon pin and connecting rod can swirl around the gudgeon pin. Piston is placed inside the cylinder so that it can have only sliding motion in one direction. The resulting mechanism is known as slider crank mechanism. It converts linear motion of slider into rotary motion of crank. Valves are provided either on cylinder head or on the side of cylinder for regulating the charge coming into the cylinder and for discharging the product of combustion from the cylinder. Top dead center or TDC is position of piston in which it is farthest from the crankshaft. Bottom dead center is position of the piston when it is nearest to the crankshaft. A stroke refers to the full travel of the piston along the cylinder in either direction. There is some space left on combustion side of piston at top dead center which is called as clearance volume. Swept volume is the volume swept by the piston in one stroke. In a spark ignition engine, liquid fuel is atomized, vaporized and mixed with air in correct proportion before being taken to engine cylinder through the intake manifolds. When the engine starts, the piston descends to cylinder's bottom from the top. Thus, the pressure inside the cylinder reduces. Simultaneously, the intake valves open and the air-fuel mixture enters the cylinder. The engine continues its motion due to inertia of moving parts and compression stroke begins. In compression stroke, both the valves are closed and charge is compressed as piston moves from bottom dead center to top dead center. As a result of compression, the pressure and temperature of charge increases to high value. Very shortly, when the piston reaches top dead center during the compression stroke, the air-fuel mixture is ignited by a spark plug. Unlike the diesel engine, the combustion process in spark ignition engine is for very short period of time and therefore the piston has very small movement during the combustion. Therefore, the volume of combustion chamber practically remains constant and thus heat addition process can be approximated as constant volume process in petrol engine. Due to the rise in pressure, the piston is moved down with great force and hot gases expands. Thus, work is done on piston by flue gases and some of the heat is converted into mechanical work during this process. As piston moves from bottom dead center to top dead center, the exhaust valves opens and piston pushes out the product of combustion from engine cylinder to atmosphere. This completes the cycle and engine cylinder is again ready to suck the charge. It may be noted that power is developed by engine only during power stroke. In all the other strokes, power is required by engine to continue its motion. During the power stroke, work developed by engine is much higher than required by the load, which causes engine to accelerate and speed of engine increases. Energy is required by engine in suction, compression and exhaust stroke. Especially during compression stroke, considerable amount of energy is required by engine to compress the charge to high pressure and temperature. This energy comes from the kinetic energy stored in moving parts attached to engine by slowing them down, and there is fluctuation of speed. A flywheel is connected to limit this fluctuation of speed. A flywheel is wheel with high moment of inertia, which means more energy is required to increase or decrease its rotational speed, or in other words, to accelerate or decelerate it. When excess energy is developed by engine during power stroke, the excess energy is stored in flywheel with overall smaller acceleration. And when energy is required by engine during compression and other strokes, the energy is provided by flywheel by decelerating itself by a small amount. Thus flywheel reduces the fluctuation of speed of engine. The electric spark has to happen at exactly the right time or the engine will not run properly. For example, if the spark occurs much before the piston reaches the top dead center, the fuel will pre-ignite and the increased pressure may lead the piston to move in wrong direction, which will eventually stop the engine. Newer engines typically use computerized ignition system for controlling the timing of spark. The valves are controlled by camshaft. The camshaft is connected to crankshaft through appropriate speed reduction mechanism.